to observe the celestial bodies' orbits and control the speed of time to see their movements. Target audience: students, amateur astronomers, and anyone with an interest in space and celestial mechanics. Key features: an interactive 3D model of the Jovian system, accurate representation of Jupiter and the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. Animated orbits that demonstrate the moon's movement around Jupiter. A user-controlled slider to adjust the simulation speed from paused to highly accelerated. A real-time speed setting, 1x, that reflects the actual orbital periods. Intuitive touch controls for navigating the 3D space, rotate, zoom. 2. User interface mobile phone. Layout: a single page. Full screen interface designed for a portrait iPhone view. The vast majority of the screen, approximately 85%, is dedicated to the 3D canvas displaying the simulation. A semi-transparent control panel is overlaid at the bottom of the screen, approximately 15%. Main view, 3D canvas. Background: a static, high-quality starfield image to represent deep space. Central object: a large, detailed 3D model of Jupiter is positioned in the center. It should rotate slowly on its axis to show features like the Great Red Spot. Satellite: the 4 Galilean moons are rendered as smaller 3D spheres orbiting Jupiter. Their visual size should be relative to each other: Ganymede, Callisto, Io, Europa. Orbital paths: each moon's orbital path is visualized as a faint, glowing elliptical line, making it easy to track their trajectory. Control panel, bottom overlay. Speed slider: a prominent horizontal slider is the main control element. Label: simulation speed is displayed above the slider. Range: the slider goes from pause on the far left to max on the far right. Markers: a clear marker indicates the 1x real-time position. Value display: a live text display next to the slider shows the current speed multiplier E. G, comma, speed. 5x. Reset button fles dance lessons contraire desaigo illes deune montre. A single icon button, E. G, comma, a circular arrow or a home icon located in the corner of the control panel. Tapping it resets the camera to its default position and zoom level. 3. Functionality gear. Initial state: when the application loads, the 3D simulation begins immediately. The default simulation speed is set to a moderately high value, e. g, 1000 times, so the user can see movement instantly. The camera starts at a default wide-angle view, showing Jupiter and the complete orbits of all 4 moons.
3D simulation et animation.
Jupiter. The planet rotates on its axis at a constant, slow speed. Moon. Orbits. Each moon travels along its predefined orbital path. The animation loop continuously updates their positions. Realism at 1x speed. When the speed slider is set to 1x real time, the orbital periods of the moons must be proportional to reality. For example, Io orbital period 1, 8 days, must complete its orbit much faster than Callisto, orbital period 16, 7 days. The visual movement should accurately reflect these relative differences. Scaling. for clear visibility on a small screen. The sizes of the moons and the distances between them and Jupiter will be scaled down. However, the relative sizes and relative orbital distances should be maintained for educational accuracy. User interactions. Adjust speed. Dragging the speed slider thumb immediately and smoothly changes the animation speed of the orbiting moons. Setting the slider to pause completely freezes the moons in their current positions. Jupiter continues its slow rotation. Requirements. Specifications update, version 1.1. Based on your feedback about the planets appearing black and not being visually visible, here are the updated specifications. 1. Specifications: ringed planet. Application name: Jupiter's aurora. Purpose: to provide an interactive and educational 3D simulation of Jupiter and its 4 largest moons, the Galilean moons, with enhanced visibility and realistic coloring. Target audience: students, amateur astronomers, and anyone with an interest in space and celestial mechanics. Key features: an interactive 3D model of the Jovian system with improved lighting and visibility. Enhanced visual representation. Jupiter and moons now feature realistic colors and improved lighting to ensure clear visibility. Accurate representation of Jupiter and the 4 Galilean moons. Europa. And Callisto. Animated orbits that demonstrate the moon's movement around Jupiter. A user-controlled slider to adjust the simulation speed from paused to highly accelerated. A real-time speed setting, 1 times, that reflects the actual orbital periods. Intuitive touch controls for navigating the 3D space, rotate, zoom. 2. User interface: mobile phone. Liu. Same as previous version.
Main view, 3D canvas.
Background. A dark space background that provides good contrast.
Central object.
Jupiter rendered with its characteristic orange-brown bands and the great red spot.
Satellite.
Each moon has distinct, realistic coloring. You're right. Making the speed slider more granular and within a more intuitive range will greatly improve the user experience. I've updated the simulation to reflect your request. The speed slider now ranges from 0, pause, to 5 times, max. Requirements. Requirements. You are absolutely right. My apologies for overlooking that crucial step. The final code must be encapsulated for the LLM to generate the app correctly. Here are the corrected specifications for version 1. 2. With the complete single-page application code properly encapsulated. Version 1. 2. 1. Specifications: Ringed Planet. Application name: Jupiter's Aurora.